not incredibly exciting. Hey there, welcome everybody to Astronomy Daily Live. Come on in, come on in. We're going to sit here for the next little bit, hours or so, and think and talk astronomy and space and, you know, nerdy things that run the world. So, that's how it is. The nerds did actually win. They continue to win, and they probably always will because they're the ones in the know, right? So cheers. Well, welcome. Come on in. Come on in. I'm gonna look at my chat here really quick and see what's going on over there. Uncle Bill, nice to see you. So on the panel is a well-lit, again, Bobby.
Hey, what's up, everyone? Good to see y'all. Welcome, welcome.
That's fantastic. Fantastic. So, yeah, hope everything is okay over on your part of the planet there. And Tom's on the panel again. Hey, Tom.
Hey, Cosmic. How's everybody doing? I hope it's well.
Yeah. So just before I hit the start broadcast button, we were talking about the SpaceX launch event today. Yeah, they I guess they were supposed to land on land over in Florida, and it looked like what I got. I went over Everyday Astronaut came out with a video supposedly explaining what happened, and Elon Musk had actually tweeted everything. So I guess there is some kind of a hydraulic pump that works those fins on the top, to sort of steer it around, and I guess that failed. And it's like one pump that serves all four of those fins. So I guess that pump failed, and that was the end of that. So I guess it actually did exactly what it was supposed to do in that kind of a situation, and it put it in the water. So actually very, very well too, right? I mean, straight up, came in really, really nice. So just a little.
Yeah.
Go ahead, Tom.
I was going to say, yeah, the rocket really worked hard to try and recover it and brought it into the right place and put it down on the shallow water and did everything it was supposed to do when it couldn't land on the solid target.
Yeah, this is definitely what I would categorize as an extremely successful and useful failure. I mean, they are going to learn so much, right? Because they, not only can they deal with, what the failure was, but they also have all this new data, right, on what that object does under those kinds of circumstances, and that's extremely useful data, right? I mean, that's useful and extremely valuable. That telemetry and everything. Oh yeah, that's going to make these rockets, I mean, so much better. So yeah, and I guess there was talk about reusing it. Elon Musk, again, I guess he tweeted out that that they should be able to use it for a internal SpaceX mission, whatever that means. So yeah, and of course, the important thing is that the cargo, right, got up there, and I guess is on its way to the space station. So mission successful, and actually, I would call this a bonus, right? I mean, definitely a bonus. Not I'm not really trying, to make it sound good, just to offer any kind of condolences, right? I mean, if they messed up, I mean, I'd be saying that, but this looks like it was sort of a legitimate, you know, hardware failure, which is going to happen, right? So they'll put in a redundant pump, they'll put in a second pump, and but yeah,
Right.
I think all that data is going to be extremely useful in making it so much better. This is probably going to allow them, to make a pretty big leap in terms of making improvements. So, yeah, a little bit of excitement. That is rocket science. So always pretty exciting. So, did you get a chance to see the full length video yet, Bobby?
Yeah, I just did, and
Okay.
I cannot believe they cut the part out about the water landing and stuff. But I watched that video on Everyday Astronaut concerning about that landing.
Yeah, good. Yeah, he does a good job. Yeah, I mean, he's really great. So, um,
Okay, if you was checking the chat, it says Uncle Bill Durham warning early landing fails was from the grid dam system running on hydraulic fluid, and it's an open system, not a closed loop. Some speculations they use the same RP1 kerosene prepared for the hydraulics.
okay, yeah. Who knows? Well, I mean, somebody probably knows by now, but yeah, that seems sort of almost like an easy fix, right? I mean, that sort of sounds like an easy fix. You got a pump failure. What you gonna do?
I wonder when it's going to be the Soyuz redo again, the take two.
They just did it yesterday, right? Was that yesterday, Tom?
Tom, you're muted.
Oops, sorry. Yeah, I had it on mute. Yeah, the Soyuz sent the astronauts to ISS yesterday.
And they're up there, right? I mean, it was a short flight. It was like,
Yeah, it was only like 6 hours, I think, or something like that between the launch and the docking. So they took the direct route.
yeah, okay.
Well, at least it's all good for there. They now got more members of the ISS now.
Yeah, it's a full ship, right? They probably have 6 up there now.
Can't remember if they have 5 or 6. I do know the crew that was there is coming back here pretty soon.
Yeah, they have a switch over.
Yeah.
Period. But yeah. So I didn't see any kind of like final report or anything on the mishap with the Soyuz before. So maybe that's still ongoing. They sort of got the basic idea that whatever failed they could easily fix. Heard anything about that?
I did read something about it. I don't think that was a final report, though. I think they were still looking into it for the details.
Okay. All right. Well, cool. Yeah. So, that was the number 4 rocket launch in 3 days, right? Is that how that works? I think so.
Yep, I think so.
Yeah. So that's pretty cool. It's well, we're we're really, really, really early in this game. I think, we could accelerate pretty easily. Um, uh, at least I hope so. You know, you sort of have so many players now that a single failure doesn't bring everything to a halt, right? I mean, in like the space shuttle days, right? At least in terms of well, yeah, I guess not even then, right? I mean, space shuttle days, they wouldn't ground all rockets, I don't think. Probably not. But yeah, it just sort of seems as though, now there seems to be just, so many more players that one failure isn't going to stop anybody else. They're just going to plow on. So pretty exciting times. All right, well, cool. Let's see. I'm looking at the chat. So Uncle Bill is over there still. Good. Let's see. I was looking at my data that I took the other night of this field of stars. Now it's only a few, but there is a definite pattern there. And so I guess what I'll do is I'll sort of share that, let you see what I'm sort of contending with there for a little while here. Okay, I think I'm there. So I'll share my screen and hide that, and we'll go.
You can see my dog.
Yes. Yeah. That's about all I can see. That's a big one. Looks like a puppy though still.
He's about 3 years old.
Oh, okay. All right, cool. All right, so here's what I'm looking at. Okay, the image on the left is the field of view that I've got through my scope, right? So this is about 12 arc minutes all the way across here, and about 9 arc minutes all the way across here, right? So this is about it's like one quarter or so of the size of the full moon. So it's a really, really, really small patch of sky, right? So what I have over here, and actually I'm going to change this. I think I've still got the plotting thing going, so I can just change it here a little bit. Let's hold on. I've got a little. Of course, I've got a little Perl script to help me with all this. Change that to 15. And I'm going to run this again. And we'll do this. This is, let me change that. And make those stars a little smaller. Let's go one more. Okay. So here is my star chart, right? And I've decided just sort of arbitrarily to choose an area that is centered on 4 hours right ascension and 1 degree declination, right? So 60 degrees is 4 hours of right ascension. Every 1 hour of ascension is 15 degrees So 15 times 4 is 60. So as you can see, this entire circle here is what? 4 degrees this way and 4 degrees that way, right? So relatively big patch of the sky. The full moon, right, would fit in like this little bottom square, right? If you could make a circle here, that's how big the moon would be here. But hope you can see this little purple rectangle. That is my field of view. So that's this, right? And I have it centered on my first target star, which I think I pointed to the other night. But what I got was this. And so what I'm seeing, right, is a bright star, and then a faint star right next to it, pretty close to it, and then this guy up here, and this faint guy way down here, right? So there's my pattern, right? And I can sort of draw a line here, and it goes about halfway in between, right? So got a pretty recognizable pattern there. And when I look on my chart over here, I definitely do not see that pattern anywhere that would fit inside this little box. Don't see it anywhere at all. So that's sort of the dilemma. I'm not quite sure. The pointing the other night was probably the best I've ever seen it, right? I did an alignment, and I'll just sort of keep this here. Maybe you can look at it. I did an alignment using Altair and Vega. So those were sort of relatively low over in the west. And then I did a number of tests, right? The slew to Mars, right? Well, Mars, it calculates a certain right ascension and declination. And then it slews there. And it put Mars right in this small field of view, right? That told it to move to Fomalhaut, right, which was just below Mars. It got that one too, right? So then I said, okay, I'm going to test this thing. I had it go over to Capella, which is on the other side of the sky, and it put Capella in this small field of view. Did a couple other stars too, I think. Aldebaran, and then I think I went back to Altair. So, you know, I tested this thing, and the pointing was really, really good, right? So then I told it to point here. And this is where it landed. And I am just not seeing, you know, assume that this is my bright star, right? Assume that this is this, okay? Well, then in this little field of view here, where's that, and where's that, and where's that? Should be able to see those in here. There is nothing. There's a couple of really, really extremely faint. These stars, the smallest ones on here go down to 15th magnitude, right? Now, there is no way that any of these are 15th, right? These, my guess is that they're probably maybe about, I don't know, this one maybe 11th, maybe, more like 10th. So, yeah, I'm just, I just don't know. Not quite sure. Not quite sure. And, you know, there are places where it's a little bit close, but not close enough. So, for instance, here I can zoom in a little bit here. Let's go 60 to 59. I think I've got that one. Oh no, I guess I don't. Okay, let's go 60 to 59. That again. 59, and we'll go 1 to 2. 1 to 2. Okay, so I've sort of zoomed in here a little bit. Let me change this. Star's a little bigger. So I thought for a little while that maybe this guy was my bright one and this one next to it. But yeah, that just doesn't work at all. So here's a bright one next to a faint one. But oh, wait a minute. I wonder if that's it. See, I knew that this might help. Let's see, it's sort of flipped around a little bit. But, oh, wow, okay, I might have found it, right? Because if you see this bright one and the faint one, if you draw a line, it goes right in between these two. I guess the problem is there's some flipping going on, I think.
Uncle Bill Duran, he's going to step away about 30 minutes, so I guess see you later, Uncle Bill.
Okie dokie. Huh, okay, well, you know, I might have just figured that out. I'm a little surprised that I can see something quite that faint. So I'm going to have to look at, I guess, my other data and see if I can get any more confirmation of sort of stars around it. Because, yeah, actually, if this is it, right, then my bright star is going to be maybe down around over here, right? If I were to extend this over. So, okay. Well, maybe I did find it there. No, well, yeah, that actually makes sense, right? Because if you look at the size of my box, right, if you sort of rotate that around, wow, okay, that might actually work. That might actually work. You might have seen that happen. Okay, well, cool. I thought I was lost, but yeah, I think I might have found it there.
Good for you. I still don't see the pattern, but
Okay, here. Let's try. So I've got bright and faint, right? And here's bright and faint, right? So you sort of have to do this in your head. I can, let's see, is there any way that I can, yeah, I'd have to think about how this would have to be rotated and flipped.
well, I think the important part is that you understand what needs to be done. 'Cause,
Yeah. Well, yeah, I think I am definitely seeing a pattern. Do you see this triangle here? 1, 2, 3, and 1, 2, 3.
Yep.
1, 2, 3, and then this little guy on the end. I think that's it.
Okay.
I think that's it. Yeah. All right. Well, I will have to. I'll have to work on confirming that a little bit because, yeah, that got me. I guess I was expecting these guys to be a little bit brighter. So, well, cool. Very cool. That was easy. I like it. All right, well, let's get back to that. I think, what we haven't done in quite a while is an object of the day. And I think I'm inclined to do an NGC object. And we can actually have Nightbot do it again. So let's do that.
All right, go Nightbot.
We have a NGC command. Supposedly, it chooses a random number between 1 and 7,840. So here we go. I'm going to hit it on the chat. Bam. Come on, Nightbot. I think that was the command. There it is. 5071. All right. Let's take a look at NGC 5071. Let's see. I'm going to open up a new window, I guess. Over to Sinbad, and then I will share my screen. Dun, 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 dun. Wow. Well, I was sort of hoping that if I actually was put on the spot with that chart and that image, that something would happen and I would find it. So that worked out really well. I like it. All right, hide that. Now I forgot what it was already. 5071. 5071. So most likely, right? It's a galaxy. Most likely, 5071. But let's see. We can sort of approximate its right ascension by its number. So 5071 divided by 7840, and then times 24, puts it at about 15 hours, 15 and a half hours. So let's see how close that is. Sometimes it's close and sometimes it's not. See, that's not very close. That's a couple hours off. So yeah, that just shows that the density of galaxies isn't uniform, right? They tend to clump up, and yep, that's what they do. Especially in this area. This looks like it's around Virgo. Can't be absolutely sure where precisely that is, but I think that's about the right neighborhood for that. So yeah, celestial coordinates 13 hours, 18 minutes, 37 seconds, and then a declination of 7 degrees, 56 minutes, 7 seconds, almost 8 seconds. Looks like a nice little, okay, they're calling it, are they calling it an elliptical galaxy? Doesn't that look like a spiral? I don't know. We'll get back to that. Pretty darn faint. This U and G magnitude, especially the G, is sort of the closest to our visual magnitude. So 14.9, that's pretty faint. It's pretty small too, right? It's what, 30 arc seconds by what, about 20 arc seconds? So yeah, that's a tiny little thing, most likely pretty far. when they're that small, can't really, yeah, I don't know. You know, that's a kind of a weird shape, right? It looks like it's got some structure, maybe not. I didn't think that ellipticals had any discernible structure. They were just sort of spheroids. So the usual different names for these guys. Nothing's too extraordinary stands out there. Ooh, very understudied. Look at that. Oh, boo-hoo-hoo. Look at that. 12. Only 12 papers supposedly mention this terribly neglected galaxy. You know how many trillions of planets are there? We're not talking about it. So many interesting things, and we don't have a clue. Don't. Oh, wow. So it doesn't even look like they have a distance. Let's see. Oh, gotta do this one. No, there's not even a distance measurement. Ah, that's just sad. So they've got a velocity, and it's pretty high, all right? 13,000 kilometers per hour. I think that's per hour. That's moving pretty fast. So my guess is that, you know, at least as far as the theory goes, if it's moving that fast, it's probably pretty far away.
I found a magnitude of 14.5, but not much else about this.
Yeah, I think that's yeah, that pretty much agrees with what it's got here. So it's much brighter in the infrared, right? JH and K. Look at K is brighter than 11th, so it's pretty bright in the infrared, but pretty faint in the visible, and everywhere else it looks like. So yeah, that's pretty sad. Let's see if any of these papers at all, the cold galaxies. I wonder if this is considered a cold galaxy. Just looking at the rest, it looks like mostly everything else is just like surveys and catalogs. It's an image database. That's kind of interesting, maybe. Probably has some great pictures in it, but let's see if our object of the day is mentioned. It's supposed to be, right? That's how these things are supposed to be placed here. But I've found that oftentimes they aren't mentioned at all. So, sorry, I'm going to go back to the chat. 5071. 5071. See, it's not mentioned. So, but sometimes they name them something else, right? So we need to look and see. Yeah, they've got well, there's a PGC LIDA number. I wonder, did we see a LIDA? For some reason, I seem to recall these names. LIDA, yeah. 46375. So 46375. Oh no, it's not there either.
I don't know how they say that it's in the paper.
I don't know.
But it's not.
Yeah, I've known it for a while. Okay, so all right. There's also, well, is there like an MCG or UGC number? No, I don't see one. Shoot. There's a KUG. KUG. Nope. Oh, so frustrating. Science is just a frustration. Just one frustration after another. Can't find stuff. It's awful. Yeah.
I guess everybody suffered from I can't find crap.
UGC.
Or I can't find blank.
Yeah. Yeah, the only one I see is a Alita number 46375, and that is definitely. See, I don't know why. Oh, here we go. Sample page of the present catalog. I wonder if this catalog is online anywhere. I mean, this was published back in '96, so you know that's going back a little ways. I guess they probably wouldn't have it online yet. That's too bad. I'll bet you it's probably mentioned, but yeah, I mean, it's just not here because they just provide a little sample, right? So, all right, let's, there was the cold galaxies. I don't really know what a cold galaxy is anyway. Here, let's just go right to the paper. Come on, Slowpoke. So we use 350 micron angular diameter estimates from Planck, which is or was a some kind of spacecraft. Oh, I don't remember what the details there are. If anybody knows, just let me know. Let's see, to test the idea that some galaxies contain exceptionally cold dust. So yeah, that's pretty cold. Since colder dust implies a lower surface brightness radiation field illuminating the dust, and hence a greater physical extent for a given luminosity, the galaxies identified from their spectral energy distributions as containing cold dust do indeed show the expected larger 350 micron diameters. I guess that's dust diameters of dust particles. Yes. So, all right, well, cool. Cold dust in submillimeter galaxies has also been investigated by blah, 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 blah. Surface brightness ratios at 250, 350, and 500 micron. That's how I would read that. To explore the relative contribution of newly formed and old stars to dust heating. Huh, okay. Well, let's see if our galaxy is in here. That's what we really want to know. I haven't seen it yet, but I should probably just do a search for it. Go back up to the top here. 5071? Is that it? It's right there. Let's zoom in on that. What is this? Can't see it because it's highlighted, but here it is. It's that blue dot right there. So I don't know what we're seeing here. I think that was the only mention of it. Yeah. 1 of 1. So it only shows up in a plot. Let's see if we can make some sense of this plot here. So the observed Planck 857 gigahertz Fourth half max versus optical diameter. Oh yeah, I'm not quite sure what these are. Cirrus galaxies. Ooh, I'm stepping out of my realm of knowledge for sure. But I guess it is mentioned once. There it is, that little blue dot. Unfortunately, yeah, there's no way I'm going to be able to interpret that. Nope, not easy. Okay, well. Let's see if there's anything else interesting. Doesn't. Oh, here's 5701. Oh, did I make a mistake? Did I? I don't think so. 5071. Oh, that's kind of funny. It's the wrong galaxy, of course, but that's kind of a cool one, though. Wow. Why couldn't we pick that one? That's kind of a cool looking one. 5701.
Yeah, ask for random, you get random.
I guess so. I guess so. That's how it goes. That's how it goes. Well, we'll have to try to remember this. You know, see if we can jump on to 5701 at some point. It kind of looks like a cool looking galaxy there. These are the they just overplot what I assume are I guess they're talking about sub-millimeter emission here. So yeah, you know, they're just looking at different wavelengths, right? This grayscale in the back here probably is some kind of optical image, and then superimposed on that is the sub-millimeter image. And yeah, you know, everything more or less looks like it's in the same place. It's even you know, tracing out these stars and stuff too. So pretty cool. But yeah, 5701. That's kind of funny. Let's see if there's anything else here. Just a bunch of tables. Cold dust components. So I guess they're saying that they are finding this cold dust. Huh. That's pretty cold. Let's see, anything else? GC 1617. Okay. Well, dare we see if HST has ever looked at this thing? I have my extreme doubts, but look anyway. So 5071. All right, not a chance. Not a chance. No way. Yeah, no way. All right, but I think I have to. 5701. Oh, there's no 5701s either? Oh, man. Really? That's not fair. Oh, well. Okay. All right. Well, let's go back and see if there's anything else. Well, we haven't actually looked at it yet, so we should probably do that. Galaxy groups, outflows in sodium excess objects. Not quite sure what's so interesting about that. Huh. Sodium excess. So here's another reference to sodium excess. I wonder why that's so interesting. Let's see. On the nature of sodium excess. Oh, well, hey, that probably might explain something. Let's see. It is so incredibly awesome to be able to just access this just like that. That's why you really won't hear me complain much about speed or anything like that, because it's just, almost regardless of the quality of the access, just having access is really just absolutely amazing. Maybe I'm showing my age a little bit, but yeah, this is great stuff. Wow. Okay, so these guys are over in Korea and the UK. Cool. So several studies have reported the presence of sodium excess objects that have neutral atomic absorption lines at 5895 and 8190 that are deeper than expected based on stellar population models that match the stellar continuum. Their origin is therefore hotly debated. So these folks proposed that low-mass stars, less than 0.3 solar masses, are more prevalent in massive early-type galaxies, which may lead to a strong sodium-1 8190 line strength. Optical wavelengths such as the sodium D line, magnesium B, iron 5270. Okay, so yeah, all right. Well, they just want to compare this, right, to other known lines, see if it does the same thing. Okay. Well, let's see. Nope, not seeing 5071 there. I wonder, I'm not quite sure what kind of context that would even be in. Sloan Digital Sky Survey. Huh. I'm not quite sure what a NEO is in this context. I interpret that acronym in a different way. Because they're talking about galaxies. Okay, NEO. Here it is. So, sodium D excess objects. So that's an NEO. Oh my gosh.
Probably shouldn't have used that acronym.
That's bad. That is just bad. Yeah. All right. Sodium excess object. That's all a NEO is in just this context alone. Everywhere else, it's a near Earth object.
That's right.
Hey, all right, that hurts. But as you can see, it's relatively painless to navigate this, right? So, here's another one, right? NDO, right? And if you go back far enough, you'll see its first reference, and that's where they define it, right? That's just not fair. So, okay. So NEOs and NDOs they're talking about. So that's just crazy. So here are some spectra. I'm not going to get into this much. Spectra are absolutely amazing. They tell us so much. It's pretty incredible. But yeah, I'm trying to see if there's some kind of context here for our object NGC 5071. That yeah, I'd like to grab onto something here, but probably not going to have any luck with that. This is a lot of statistical work and fitting to models and whatnot. Yeah, this is well beyond the scope of this brain. Yeah, this is for much larger brains. Let's see. Still trying to see if I can find some kind of context for this terribly neglected galaxy. But it really doesn't look like there's any kind of reference to it. So, yeah. That's what I mean. You know, it's like, why would this be listed? Especially on Sinbad. You know, Sinbad, I always thought, you know, was pretty good at this stuff. But, yeah, I'm not quite sure why this paper is here. There doesn't seem to be any kind of reference or anything. Maybe there is. It's just hard to find. So, yeah. But this is definitely not, you know, the only time I've seen this. So you know, I guess it's just sort of researcher beware, right? You know, you can't be, you know, doing some kind of report and say, oh, okay, you know, there's 12 references to this object here. Well, we've looked at least a couple, and I think what, out of the 2 or 3 or so, I think we saw one reference, and that was a data point on a plot. So, yeah, do the rest of these have them? Don't know. Might be an interesting research topic, but that's for somebody else to work on.
Well, there's plenty of work for everybody to do, right?
Yeah. But you know, I really do hate to see these things neglected. You know, because it just, you know, we think we know so much, and the fact of the matter is that we just don't. And you know, observing this with all of our capabilities adds, you know, some pieces of information to the pot that you know, might be useful. Who knows? But that's a pretty pretty sad looking.
Like a swallow, huh?
What's that, Bobby?
Like a hard pill to swallow.
Yeah. So this is kind of an unusually shaped galaxy, though. So this is the Sloan Digital Sky Survey, which is, yeah, I mean, it's a pretty good survey. Here's more of a grayscale. Okay, yep. Pan stars. What else do we got here? don't know what these other ones are. Oh, here's the same thing in blue. Okay, yeah, it sort of looks like Sloan is sort of the best, but yeah, that's I'd even question the morphology type, because they're calling this an elliptical, and I don't know. I mean, looks like an irregular if nothing else. It's got this weird thing here.
Welcome back, Uncle Bill Doran.
Hey there, Uncle Bill. So we're looking at the object of the day. This is NGC 5071, and it's one of those very neglected objects that has half a trillion stars, and nobody cares. Nobody cares about it. It's really small. It's really faint. It's just out there. But it does have at least an NGC number, which is significant. That's got to be one of the fainter NGC objects. Yeah, I don't think that they go much fainter than 15th or so. And yeah, if this is at like 14 and a half, or 14.9 or whatever it is, yeah, that's right on the edge of faintness as far as the NGC catalog goes. But yeah, there's looks like there's some similar sized galaxies here, so maybe they're sort of the same distance away, whatever that is. It hasn't even been measured. But yeah, it looks like it might be part of a cluster. Most galaxies are, they're associated with other galaxies. This one, yeah, hard to tell. There's a lot of galaxies in here. But, if you assume that this galaxy and this galaxy are the same physical size, intrinsic size, then you have to conclude that this one is further away because it's smaller. So that may not be true, right? This might be just a very, very small galaxy compared to this one at the same distance. So can't really tell by looking. That's a really pretty spiral. That's nice. But yeah, all right. So he's got some neighbors. See, this one sort of looks like an elliptical too, but it's got this funky arm coming out there. What's going on there? Who knows? That one's probably not studied either. Sometimes I can be a cynic. Let's see, anything else around? Pretty much everything else, right, is a foreground star, is a star in our galaxy. So here's a galaxy and a star that are almost exactly lined up. Look at that. I'm kind of wondering what that is. I'm thinking that's an optical artifact from this star, but it kind of coincidentally lines up with this galaxy. It's too bad, too. The glare from this star is really knocking this galaxy out. This looks like a pretty nice edge on there. This looks like an elliptical galaxy. Does that look like a galaxy or a star? It's kind of hard to tell. I guess it's a star. Let's see. Okay, so here's 5071. Let's go up this way. There's a nice almost edge on. Look at those clumps in there. Now some of this looks like some kind of processing artifact, these reddish clumps, but I'm talking about just the clumps of color in here. Pretty amazing. Something interesting going on everywhere. Look at that weird one. Huh. again, probably completely almost unknown, not paid attention to. Yeah, it's a nice patch of the sky. There's lots of galaxies. Like I said, this is somewhere in the Virgo area. Can't be exactly sure where unless I looked at the chart. But yeah, somewhere in the Virgo area, maybe a little bit south of Virgo. Not quite sure. But yeah, I like galaxies. I think they're fabulous. It's sort of, oh, okay, there it goes. Like, wow, that's kind of pixelated, but that's a pretty one. Cool. All right. Well, you know, I'm really, really glad that this live stream happened because I think I found my field of view on that with that data. So I think my pointing probably wasn't as bad as I thought. So cool. All right. Well, I'm looking at the time, and it looks like it's about time to get on out of here again. So I've only gone through half of this HOH. Terrible. All right. Well, it is 2 minutes after 3 hours UTC. So yeah, I think it's about time to get on out of here for today. But this is a daily live stream for the most part. So yeah, I think tomorrow I will definitely be here again. I've heard once again that horrible 4-letter word that just shall not be spoken. Might be on its way. SNOW. But it's not going to last. It's not going to last. So, but
You really get snow in Arizona? I know, like, it snowed here last year.
oh yeah, and you know, Arizona is really diverse. So up near Flagstaff and everything, it's like a Northwest winter. It starts snowing in November, October, and it doesn't stop up there until April or so. Where I am, yeah, we'll get a little bit of snow, but that's what I say. The great thing about it, best thing about it, is that it doesn't last. That's my favorite part about the whole thing. So, all right, well, with that, I'm going to get out of here for now. So take care, everybody. Thanks for coming in again. You know, this is a lot of fun, and it's just great, you know, to share a passion and, you know, talk some astronomy for a little while. You know, pretty much regardless of what it is, there's always things to talk about in terms of astronomy and science and all of that. It's just an amazing place. So yeah, always lots to find out, lots to think about. So yeah, let's do it again tomorrow. I will be here. So have a great evening, a great day. Make sure to subscribe if you haven't yet. You can hit the thumbs up, the thumbs down, whichever you prefer. Yeah, all right. Take care, everybody. I will see you in a little less than one spin of this tiny little planet. All right. Bye-bye, everybody. Bye.